Have you ever wondered what Earth was like before life? Before the oceans? Before even the moon? Was it the primordial ball of rock and fire that everyone imagines? Or could it have actually been something much colder? Welcome to the Wanderer's Expanse. Today, we're going back in time 4.5 billion years, back when planet Earth was just getting started. My name is Hayden, and this is the Hadean Eon. Life on Earth before life on Earth. The Hadean Eon is Earth's earliest geologic period, even though technically no rocks are known to have survived from this time. It spanned from about 4.5 to 4 billion years ago, from Earth's formation up until the earliest known rock formations found in places like Canada and Australia. Being the very beginning of Earth also means that for these first hundreds of millions of years, Earth was a germaphobe's paradise. While estimates for the beginning of life vary based on the line of evidence, the general range is between 4 and 4.2 billion years ago. It's complicated. But let's kick things off with a nice, slow, serene start to this adventure. And slam a planet the size of Mars into this primordial rock! This theoretical planet, often called Theia, would have smashed into our proto-Earth, immediately vaporizing up to 20% of Earth's mantle, and melting the rest into a worldwide magma ocean. Most of the little water and atmosphere Earth might have had at this time would have been expelled into the vacuum of space, while temperatures at the surface may have reached up to 8,000 degrees Kelvin. Marshmallow? This nearly worldwide magma ocean would have been impossible to imagine today, with molten rock stretching from horizon to horizon. But unfortunately, you're gonna have to imagine it because we can't see it through all these rock vapor and silicate clouds. For hundreds to even 1,000 years after the impact with Theia, Earth would have remained so hot that the vaporized material from the mantle wouldn't be able to condense and would instead remain in the atmosphere. Meanwhile, out in space, some simulations predict it would have only been a matter of hours until the moon coalesced, giving us our one and only natural satellite. And that, as we all know, was when the werewolves evolved. From way out here, Earth would appear as a dark, swirling surface of clouds, lit by its burning hot atmosphere and glowing magma below. So I'm gonna get a running start, and when we land, let's talk about how Earth turned from this into the planet we all know and love. Cannonball! So, what do you think? 10 points? After the impact, Earth would have begun rapidly cooling to the point where this world that's covered in magma may have soon been a lot colder than you might think, but we'll get to that soon enough. For now, it would just take a measly 1,000 years of air that would melt steel before the rock vapor atmosphere would start to condense. You know, maybe it's good there's no life around yet. Once temperatures cooled enough, silicates would start to rain out of the atmosphere on the order of a meter a day. Basically, at one point in Earth's history, it kinda sorta rained rocks. I'm singing in the ow. I'm singing in the ow! These silicates would have fallen into a still molten magma ocean, but over time, this magma too would cool, starting from the bottom up. However, even after the magma solidified, true continental crust wouldn't have emerged yet. On today's Earth, continental crust is, on average, less dense than what's below it, allowing it to float on the mantle and remain on top. But in this worldwide magma ocean, it's actually the least dense stuff that finishes crystallizing first, at the bottom, with the heavier stuff finishing on top. Meaning that once the magma oceans had fully cooled, there would have been a period of great tectonic activity, where the lighter cumulates would begin moving towards the surface. Fun fact, you can actually observe this same process, or something similar to it, when you pour milk into your coffee, as something called Rayleigh-Taylor instabilities govern the movement of liquids with different densities. Of course, unlike coffee, you can't drink a cup of solidifying mantle. Oh, believe me, I've tried. After the magma oceans had cooled off, the temperatures on Earth would have finally dropped below the boiling point of water, which means actual rain. Finally! the amount of which would have been staggering. While impacts from asteroids and comets may have contributed some amount of water after this point, we're still talking about pretty much all the water on planet Earth. A total of 1.4 billion cubic kilometers of rainfall. This would have been a period of probably near constant precipitation, with some models showing water falling out at over 10 meters per year. What? It's the first rain ever. Don't judge me. Much later on, we'd see the crust finish differentiating and the first true continents on planet Earth. I figured I'd take a little souvenir, you know? However, by this time, the Hadean may not have been the hellish, scorched world we've come to know. Instead, the cooling that began after the giant impact may have never really stopped. You see, what I've neglected to mention is that our sun hasn't always been as bright as it is today. In fact, during the time of the Hadean, it was only outputting about 70% of its current energy. In fact, the only thing dimmer than the sun at this time would have been yo mama. Today, the sun and Earth exist in a delicate balance to keep Earth's water liquid and sustain life while not boiling away our atmosphere. So, by all reason, only a few tens of millions of years after the giant impact, Earth should have been frozen under anywhere between 1 and 100 meters of ice. So next time you're cleaning snow off your driveway, you can be grateful it's not a football field deep. But man, it is getting a little chilly. I could really go for a hot cup of solidifying mantle right now. What was once a molten ball of magma would instead become an icy landscape dotted by volcanoes and impact craters where meteors had temporarily melted the snow. But despite the sun not being as powerful, we know from several lines of evidence that there was at least some amount of liquid water on Earth during this time. And by 3.8 billion years ago, around the start of the Archean Eon, we know that it was warm enough that there weren't any glaciers on Earth at all. So, was Earth actually still warm all throughout the Hadean? To quote leading geologists, I don't know. This is what's sometimes called the faint young sun paradox, and it's one of a few lingering mysteries about Earth's earliest eon. Say that 3 times fast. The other one being where the werewolves went. In order to keep Earth warm, you'd either need a lot of geothermal energy from below or a lot of greenhouse gases. There doesn't seem to have been enough geothermal energy, even after the many impacts Earth would suffer, but greenhouse gases might provide a solution. Today, greenhouse gases like carbon dioxide and methane are produced through the natural processes of living things. But, right, the whole before life on Earth thing. However, natural CO2, plus, I mean, we need like a lot of cows. However, natural CO2 in the air and methane produced at places like hydrothermal vents may have been enough to insulate the little energy Earth did receive. Ultimately, so little has been preserved from this primordial time that it's just difficult to know for sure. But no matter if it was a scorching hot rock or buried under ice and snow, sometimes, even though things can look like hell on Earth, maybe it's just setting the stage for something special. And thus our adventure comes to a close. Earth warms up, cools down, the first life evolves, but maybe that's a journey for another time. If you've watched this far and enjoyed, why not leave a like and subscribe to not miss out on future adventures. As always, I'm not an expert, but I do my best to make sure everything presented is as factual as possible. Some sources are down below. As always, I've been your Arbiter, and thanks for visiting the Wanderer's Expanse. You know, it really melts your stress away, and your flesh, and your bones.